So we are beginning module 6 now, and the lesson 6.1 is simplifying expressions. And our learning target, I can simplify algebraic expressions by identifying and combining like terms. So that's what our learning target is. And there are certain vocabulary that we are going to learn, like coefficient, constant, like terms, and simplest form terms. Okay. So let's go ahead, just look at some of these examples that I have put up over here so that we can identify what the like terms are. And if I look at like terms, basically, what does that mean? It means when we are adding or subtracting signs, or when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. And like terms contain the same variables to the same power. For example, if I have 3x squared and I have negative 7x squared, these are like terms because the variables and the exponents are exactly the same. So if I look over here, this one and this one, these two are basically like terms. This one and this one, 8x and 6x, are like terms. And negative 1 and 5 tenth x. This also because the variable is the same, x, and x over here. Then if I look at numbers, which are the like terms, I have 5, I have negative 12, and I have 1 half. These are the same kind of terms, so they are called like terms, okay? Because like terms can be added or subtracted, okay? If I say 8x and negative 9x squared, these are not like terms because the exponents are different. And the numerical factor of a term that contains a variable is called the coefficient of the variable. So if I look at 6x, 6 is the coefficient of the variable. Coefficient always comes before the variable. Okay, coefficient always comes before the variable. So if I look at this over here, these terms are separated by addition. So when I say terms are separated by addition or subtraction. So if I look at these, I have 3 different terms here. I have 3 terms, okay? And then my like terms would be, see, both of them have x. So these two are like terms. These are like terms. If this was negative 4x squared, it would be an unlike term, okay? And then if I look a term without a variable, is called a constant. Okay, so these are a couple of things that I wanted to talk about in the vocabulary before moving on to this lesson. Okay, so once again, if we are going to sort the like terms, I am just going to underline with the same or circle with the same color. If I look at the top, these are my like terms: 5, negative 12, and 1 half. These 3 are like terms. If I look at 8x, 6x, negative 1 and 5 tenth x. So those 3 are like terms. And then I'm left with negative 9x squared and 30x squared. These are like terms. Okay, so just remember they've got to have the same variable with the same exponent to be like terms. So let's solve some problems. And if I say that my question is, okay, the cost of a jacket J, okay, after a 5% markup can be represented by the expression J plus, this is 5%, because 5% in decimal form is 500th J. So if I have something like this given to me, and we are supposed to simplify this expression. So we are going to identify the property that if I don't have a number or a coefficient written in front of a variable, that basically means it is 1. So that is 1j, because based on the multiplication property of 1, anything times 1 is the number itself. So j times 1 would be j. So if I've got j written over here, that means there's 1j. Okay, so if I have to simplify this, basically what am I doing? I'm doing 1j plus 500j. Okay, and I combine the like terms, and when I combine the like terms, what are the like terms? I have the j and I have the j over here. So 1 plus 500, and I get 1 and 500th j. 1 and 500th j, and that is my answer over here for the simplifying this part. Okay, so increasing the jacket's price by 5% is the same as multiplying the price by 1 and 500. So suppose the original cost of the jacket is $35. So let's say the cost of the jacket is equal to $35. Okay, so what would be the cost after the 5% markup? So now all I need to do is I am going to take, this equation, this expression over here, and I'm saying 1 and 500 j. So instead of j, because this is the price of j right now, okay, so we are just going to substitute the values, and I say 1 and 500 times 35. Okay, and then when I multiply this, I am just going to get the cost, the 5% markup, and I am going to get $36.75. Okay, so this is how we calculate for problems like this, right? Let's do another quick example. Let's say the cost of a new pair of shoes after a 3% markup can be represented by C plus 300, okay, C plus 300C. Okay, so this is my markup. And if I had to simplify the expression, I know that C is how much? I have 1C plus I have 300C. Like terms are C and C, so I'm going to add them up, and I get 1 and 300C is my solution to this one. Okay, so then when I am simplifying it, basically that's what I am doing. All right, so let's combine like terms now and simplify numbers with different signs. Okay. So let's say I have a problem, negative 5x plus y, okay, minus, no, plus 6 minus 5y minus 3. Okay, so first I'm going to write this expression, and then I am going to rewrite subtraction as addition. Okay, because whenever there's subtraction, I'm basically doing what? Adding the opposite, or the keep, change, flip that we had talked about. Okay, so I have minus 5x plus y plus 6. This I am going to now change. Okay, because the minus 5y, what is that going to become? It's going to become plus. So here, keep, change, flip the sign. Same thing here. Okay, so plus negative 5. So I've kept 6. I've changed the minus to the plus, and then this is going to become plus a negative 5y, because think of it this way. That means it's plus, it becomes minus. All right. Same thing here. We're going to keep, change, and flip the 3 to -3. Okay, so we're going to rewrite the subtraction as addition. And then we are going to use the commutative property of addition. Okay, and that means we are going to change the order, switch it around. Okay, so that we can put like terms together. And if I'm looking over here, I can see that if I have negative 5x, this is negative 5y. Okay, so if I have negative 5x plus I have I'm going to put this and this together. So negative 5x plus y plus, I'm just going to switch the order, use the commutative property, negative 5y. I'm going to put this over here, plus 6 and plus -3, because I'm trying to put the like terms together so I can add or subtract. So now if I look over here, I have negative 5x and then I have negative 5y and I have 1y. So opposite signs, take the absolute values and subtract and give the sign of the bigger number. So then this is going to be plus -4y, because 5 minus 1 is going to give me 4, and the sign in front of the bigger number over here is negative. Okay, and then I have 6 plus -3, which is saying 6 minus 3, which is going to give me 3, and the sign in front of 6 is positive. So this is going to be plus 3. So therefore my answer here, negative 5x and plus -4y is nothing but minus 4y plus 3. Now we can see all of these terms are unlike terms. I have an x, I have a y, and I have a 3. So this is now in the simplest form once I solve it like this. Okay, so that was one example. Let's go ahead and try combining like terms, where we are now using, instead of just integers, we are going to use the fractional parts also. Okay, so here's another example. If I say 3/4 a, 3/4 a, okay, minus 2/3, minus 2/3, minus 1/2 a, minus 1/2 a, plus 5/6, plus 5/6. So first, let me just look at this problem, and I'm going to identify the like terms so that I can use the commutative property of addition or addition, and then I can switch them around so that I can group the like terms, and those I can add and subtract. I can only add and subtract like terms. Okay, so I can see I have 3/4 a and I have negative or minus 1/2 a. So these two are like terms. And then I have minus 2/3 or negative 2/3 plus 5/6. These are like terms. Okay, so I'm going to rewrite subtraction as addition. So 3/4 a, so then keep, change, flip. Okay, change the minus to the plus, change the 2/3 to the negative 2/3. So that means I'm basically flipping the sign of that number. Okay, plus, okay, again over here, keep, change, and I'm going to flip the 1/2 a to negative 1/2 a, minus 1/2 a, and then I have plus 5/6. Okay, so now here are my terms which I've rewritten subtraction as addition now. Okay, now I'm going to use the commutative property, and I am going to do, because with addition I can, just change it around or flip it around, and that is the commutative property. Like for example, 5 plus 10 is the same thing as 10 plus 5. So I can rewrite it like that, and that's called commutative property of addition. So I have 3/4 a plus negative 1/2 a, okay? And then I have plus negative 2/3 plus 5/6. Okay? So next thing we are going to do is rewrite fractions with common denominators. Because we can see that the 4 and 2 are not common. So we've got to make common denominator. Looking at this, I know that 4 is going to be my common denominator. So 3/4 a plus negative. My 2 is going to become a 4 because I need a common denominator. And 2 times 2 gives me 4. So 1 times 2 is going to give me 2. And here is my common denominator now, which will be easy for me to add or subtract. Okay. And then I have plus. Again, if I look at these two numbers, they do not have a common denominator. And so I am going to look at 3 and 6, and my common denominator is going to be 6. Okay. And plus, and I already have 5/6 here because times 1. So 3 times 2 is going to give me 6. So 2 times 2 is going to give me 4. All right. Now, once I have this set up like this, then it is very easy for me to add or subtract. So if I look at a 3a minus 2a, I am going to get 1a, okay, 1a over 4. And then if I look at these are opposite signs. So I'm going to take the bigger absolute value, which is 5/6 minus 4/6. So I get what? I get plus 1/6 because the sign in front of my bigger number is positive. Okay, so 1/4 a plus 1/6. So, I can write it like this. 1/4 a plus 1/6. There's nothing common anymore. So this is the final answer to this problem, right? Um, so learning, how to expand linear expressions, we are basically going to use the distributive property to expand linear expressions. And we had talked about distributive property in an earlier grade. And the distributive property states that to multiply a sum or difference by a number, we multiply each term inside the parentheses by the number outside the parentheses. Okay. So for example, so distributive property, for example, if I have something like this, 4x plus 2. So if I'm talking about the distributive property, okay, if I talk about the distributive property, what am I doing? I am taking each term outside the parentheses. So, and I'm multiplying with each term inside the parentheses. 4 times x is 4x. We bring the plus down. 4 times 2 is 8. Okay, so that's basically what my distributive property is. And we are now going to use this in order to solve problems to expand linear expressions. So if I'm given a problem, okay. So let's say I have, if I have to distribute over addition, and I am given 4 negative 3x plus 6. Okay, so all I'm going to do, I'm going to use the distributive property. I'm going to multiply each term with the number outside the parentheses with each term inside the parentheses. And I know that 4 times negative, so positive times negative gives me negative. So 4 times negative 3, which is negative 12x, plus 4 times 6 is going to give me 24. And now I can see that these are unlike terms. And so this becomes my final answer when I am solving this. All right. Um, let's talk about distribute over subtraction. So if I have a question, um, 2x minus 5y, okay, times 3. I have this. Now, whether I write a number in front or I write it at the back, it doesn't mean, as long as it's outside the parentheses. I am basically multiplying that with each term inside the parentheses, okay? So I am going to do, I can also read, I can put the 3 in the front. It means the same thing. If I do this, or if I write it like this, if I write it like this, 2x minus 5y, this basically means the same thing. All right. So what am I doing? I'm doing this times this and this times this, and I have the minus sign. So that's basically what it is. 3 times 2x, 3 times 2 is 6x, and then I have minus 3 times 5 because I have the positive times the negative. That gives me negative. So 3 times 5, which is minus 15y. And again, these are unlike terms. So here is my final answer. Okay. Um, let's go do one last problem. Distribute negative numbers. So distributing negative numbers. And if I say I have negative 5 and I have 2x minus 9, once again, I'm going to rewrite a subtraction as addition. All right. So if I do that, I have negative 5, I have 2x, all right, and then I have plus, this becomes your, so keep, change, flip, change this subtraction to addition, the 9 to a negative 9. Okay, so I can do this. All right, and then all I'm doing is I am multiplying each term, this with this, and negative 5 times negative 9 using the distributive property. And then I know that the negative times positive is going to give me negative. So this becomes negative 10x. And then I have negative times negative is going to give me positive. So negative 5 times negative 9 gives me 45. And then again, these are now unlike terms. And so therefore, this is going to be my solved answer in the simplest form. All right. So basically, again, in this learning target, all we are doing is we are simplifying the algebraic expressions by obviously identifying like terms. You cannot add or subtract unlike terms. So just take the like terms and add or subtract them. That means you're combining them. All right. Have a great day, y'all.